So let's get into it one time. So binomial expansion and your Taylor number, right? Firstly, let's spend some time on binomial. You would have done this already in what? In what, right? You would have done the binomial expansion, right? Right, so the binomial expansion basically is a plus b to the power n is a to the n plus nc1. Remember to find this, NCR, I think. A to the n minus 1 b plus nc2 a to the n minus 2 b squared plus all the way down until you reach a to the power, sorry, n to the power n, b to the power n. And in the middle here, I want you to remember a special, or what we call the general term. The general term is NCR a to the n minus r, b to the r. All right? This here is your binomial expansion. All right? And you use this when n is a whole number. When n is negative or a fraction, we can't use this. Right? I'll show you what to do. N over NC2. Yeah. Here's 1, so after 1 is 2. All right, so I want to show you how to apply it here.
There was nothing to us. You push me forward.
You will know that you want it here. You will know your
Yeah, actually, I could bet money, sir. I'm not here. Actually, I assume.
All right, ready? So how it's applied? Right? A is 3, B is minus x squared, n is 4. We just go and plug this in here. Because one table. All right, nice. So if we use the expansion, we just plug in A, that'll be 3 to the 4. We plug in N here, that'll be 4C1. We plug in A again, that'll be 3 to the N minus 1, so that's 4 minus 1, so that's 3. And remember that P is minus x squared. And then we continue, we follow the pattern. You will always realize that the powers here add to 4, right? So we follow the pattern until we reach 4C4. So 4C2, I keep decreasing the powers here, and I'm going to increase the powers here. right? So I read 4C2. Now I'm gonna do 4C3. So that'll be 3 to the power 1 minus x squared cubed. See, power still adding up. And last one, 4C4, 3 to the 0. You can leave out that if you want. Minus x squared all to the power of 4. Right? Then you go take calculator and work it out. Take a look here. 3 to the power of 4 is 81, right? 4C1, let's go back to it. I can make sure I can work it out now, please. It's pressing 4 and CR1. All right? Press 4 and CR1. Right? Press 4 and CR1. Yeah, how much you got? 4. Nice. 4 and CR1 is 4, right? Right? Those who online, remember you're pressing 4, look for NCR and then press 1 and you should get 4, right? So you'll get 4 by 27 minus x squared to the 1 is minus x squared. How much is 4C2? Check it fast. 4C2 is how much? 4C2 is 6. 3 squared is 9. This is minus x squared. So that'll be positive x to the 4th. 4C3 is how much? We should get 4 again by 3 by minus x to the 6. 4C1 is 1 by 1 minus to the power of 4 with positive to the power of 8. And then simplify it up a little bit. This is 81 plus 4 by, sorry, minus, right? 4 by 27 is how much? 108 or something? What's this here? 108x squared. 6 by 9, right? 6 by 9 is 54x to the 4th. This is minus 12. And then this is positive x to the 8th. Right, before I move on, any questions? William, you can do this. Remember this? Right, all you have to do is figure out a, b, and n, and you can use this formula when n is a whole number, right? Right, I'll show you what to do if n is not a whole number. Okay with that? Right, so you plug in A, B, and B, right? So this is if they ask for the full expansion, right? But suppose they ask for the x to the 4 too. You don't want to have to go and expand it out. There's a way for you to figure it out using the general too. All right? Suppose they ask, what is the coefficients of x to the 4th, right? And you don't want to do this. Or what's the coefficients of x to the 6, and you don't want to do all of this, you could go there and do the general too. All right? And I will show you what to do. Okay? So what you say? How do we figure out? All you don't forget to fill out the cash flow format. Right, and that's what the deadline to pay will be what? If it's pays wrong, it's pays wrong. But the deadline is normally I'll give all you until the March Saturday. Like about the 12th of March, 15th of March, or forget that Friday. Not next week, the week after. It have a Google form to fill out. Google form. Just fill out the Google form.
Yeah.
Right? All right, guys. So suppose you want to get, you don't want to do all of this, right? And I ask you, what's the coefficients of x to the 6? Here what you just do. What you just do is just come to the general term and try to figure out which term it actually is. We know what n is. We know n is 4. We don't know r. Let's assume we don't know r. This one is 0. Huh? A is 3. This is 4 minus r. And b is minus x squared to the power of r. Right. So here's the question. I would like to get the coefficients. I would like to get the coefficients of x to the 6. I don't want to do the whole expansion. So I know n, I know a, I know b, I know n, but I don't know r. So my question is, what value for r will help me get x to the power of 6? The value for r will be 3, because 3 by 2 will give me 6, right? And there's no x squared, there's no x term here, right? So when r is equal to 2, I will end up with, 3. When r is equal to 3, I will get 4c3 by 3 to the 4 minus 3 by minus x 2 to the power 3. When you multiply this out, put this in your calculator and factor in the minus sign, you will end up with minus 12x to the 6. So we were able to get the coefficient without having to go and do the whole expansion. Okay with that? Sometimes it's real easy where you can just watch it and figure out r. Sometimes you will have to simplify it and equate it to the value you want. All right, and I'll show you that just now. So what we could have done, if you're not figuring out r, you could multiply 2 by r, and because you want 6, you could say, well, 2r is equal to 6, so it means that r is 3. Right? That's one way to do it, and I'll show you some other solutions as well. So this general term is really useful whenever you have to find the coefficients of one term alone. You don't want to go and do all of this. All right, copy it down. Let's go again. Any questions online?
Well,
Ready? Let's go again now. Right, insert up. Right.
This is serious question. On this chapter, we don't say.
How much is it?
$8.
Right. All right, so let's try this next one here. What's that? All right, I'm going to give you an expansion. All I want you to do is just tell me what the first three terms, right? First three terms. That's all that, not all that. There's 20 years. I just want the first three terms of this expansion. First three terms of this expansion. If your number too big, just leave it in terms of NCR, right? Find the first three terms of that expansion. Right, of course, you know what A is? A is 2x. You know what B is? And you know what N is. Right? So just work out the first three terms of this expansion. Right? Do write was 2 to the power 20. Just write the first three terms. Gonna make sure you have the hang of using the formula. It's very big value, so you don't have to work it out, right? Just leave it in the factorial form. Yes, yeah. That's good. So walk down there by right, so what are the first three terms? It will be 2x to the all to the power of 20, then 20c1 by 2x to the power of 19 plus 3 to the power of 1. Plus 3, well, 3 to the positive 3 to the power of 1. That's the first term. Second term, third term will be 20c2 by 2x to the power of 18 by 3 squared. That's okay? Leave it like that because it's a big number. All right? A big number. Right, but here's what I want now. Now that I have an idea there, I want you to prove something for me. I want you to try to prove this or show this, right? Show that the ratio of the x to the sixth term over the x to the 7 term, x to the 6 term, x to the 7 term is 3 over 4x. So I want you to show that the x to the 6 term and the x to the 7 term is 3 on 4x. All right? So the big problem is, I wanted to show you all this, right? This is x to the 20. This is x to the 19, right? The next one is x to the 18. Would you go all the way down until you get x to the 6 and x to the 7? No. What you will do is you'll come to the general term. So find the term that will give you x to the 6, then find the term that will give you x to the 7 and divide them. Okay? And let's see if we get 3 over 4x. All right? Try that, please. Let's see if we get it, right? So using the general term formula, all you have to do is figure out what is R. So the calculator, you go thing. Huh? So let's see if we can figure out the. Let's see if we can figure out the x6 term. So the x6 term will be NCR, N is 20, CR, R is what? R? We don't know what R is yet, right? A is 2x to the 20 minus R and 3 to the R. So what term here, what value for R will give me what value for R will give me 6? Right? This power here has to be 6. That's okay? So for this power to be 6, it has to be x to the 20 minus R. This has to give me x is 6. So it means that 20 minus R is 6. So R is 14. That's okay? So you bring all the R's, you bring all the x's together, there's only one x. Right? So I got 14. So I'm taking off R here, taking off R here. That's 14. This is 14. And now X7 term, we can figure it out because it's easy. That'll be 20 over what? What will give us 7? How much? 13. So that'll be 2x to the 20 minus 13. 3 to the 13. And they said they want the ratio, so just put them in a calculator. Of course, please leave out the x, right? So put in a calculator, 20C14, 2 to the 6, 3 to the 14, all over 20C13, 2 to the 7, 3 to the 13. All right? And hopefully I get it. I'm a bit confused. I'm not sure how I get 14. Remember it was 20 minus r. And I want to get x to the power 6, right? So if x is equal to 20 minus r, and that has to be equal to x to the 6, these two must be equal, right? So r has to be 14. No, not the 6 2. It's the coefficient of x to the 6. X6 2.
What is x6? X2.
Yeah, that's what I'm talking about.
Oh.
Okay. Yeah. So you end up with 3 4 to the x. Right? Any questions online there? You all okay with that? Chelsea, Karina, Justin? Right? So this general term is used when you want to get 1, 2. The expansion is when you want to do more than 1. All right? Anybody confused yet? Right, but as I said, make a note that you can only use this expansion when n is a whole number. When it's negative or a fraction, we can't use this. I'm going to show you the alternative, right? Right? I get it? I get it? All right, so what will happen? What will happen if n is less than or equal to 0 or n is rational? Right? What would happen if it's less than 0 or if it's rational? Then we can't use this. Go to a calculator, find minus 4C3. Find minus 4C3 or find a quarter C3. Error. Right? Error. We can't find that in the calculator. All right? Oh, by the way, you all know where these values came from, like 4C2 and 4C3, I think? No? All right, so watch this here. Watch this here, right? Suppose you had a plus b. Suppose you had a plus b to the power 1. When you expand it, what will the coefficients of a be? Coefficients of b. And if you had to expand a to the 1, you'll get 1, right? Suppose you had a plus b squared. What will the coefficients of a be? What's the coefficient of a be? And here, so watch this here. It have this triangle called Pascal triangle, right? 1, 1, 1. Here's 1, 1, and the number in the middle is sum of these two. Here will be 1. Sum of these two is 3. Sum of these two is 3, and the next value is 1. Right? So for example, if I ask for 3C, 3C0, 3C1, 3C2, 3C3. Right? And you can do the same thing and figure out 4. 1, 1, 1 plus 4, 3 plus 3, 3 plus 1. Right? So if I ask you for 4C1, 4C2, 4C3, 4C4. Right? And you can do 5. Watch. 1, 5, 10, 10, 5, 1. Right? So your calculator could only handle whole numbers like this. Positive and whole numbers. When the Pascal triangle goes in between, you can't do it. Or when the Pascal triangle goes negative, it can't do it. All right? So your calculator can handle this. But when you end up with less than 0 or this, you have a little problem, right? So what you have to do is use this relationship here. Same thing, right? So it will be a to the n, that will be easy. But NC1 will be n over 1 factorial, right? By the same thing, a to the n minus 1b. By the way, I think this is a formula sheet, right? But you might see it and might know what to do with it, right? So I'll show you how to use it. Oh, wait, some people answer it. But you asked a question there. They're excited when I see one. No question. Sorry. Right then, when you see NC2, here what you do. NC2, you write 2 factorial underneath, and on top, you have to get 2 terms. You start with n, and you multiply it by the term before it. N minus 1. So 2 factorial means you must have 2 consecutive products. And then you do the usual thing, a to the n minus 2, b to the 2. What do you think 3 factorial will be? Sorry. What do you think NC3 will be? 3 factorial here, and on top will be the product of 3 consecutive terms. N minus 1, n minus 2. Right? And here will be a to the n minus 3, and you continue that pattern all the way down. All right? If it were simply just practicing, right? What would NC4 be? Underneath here is 4. And here will be then. That's okay? Huh? Well, technically the general term is, we cannot trick you to write R because you will have to write what? Let's make it up. What do you think NCR is? What goes underneath here? On top here, N. And what was the last term be? Here was 4 and here was 3. So the last term is what? N minus, open bracket, R minus 1. Right? So this is the general term. Okay? Right? Make a note of this. It's in the formula sheet. You will see it in the formula sheet, right? In the formula sheet, you will see this and this, and you'll also see 1 plus x. Some books like to use 1 plus x, that general expansion. I don't really like to use it so much, but people use it.
So is it not?
Well, it'll be a little bigger than that. It'll be a little bigger than that. Check it and see. Check it both.
12 ounces is crazy, yeah? If there are 12 ounces.
Copy it down and do one for me now. Right? Do 1 minus x to the power of a half or square root. Do the first 1, 2, 3, 4 terms. Do the first 4 terms of 1 minus x to the power of a half. And he finishes. Also, I wanted to summary. So it's coming. First 4 terms, 1, 2, 3, 4. First 4 terms. That's can you have it using it? Yeah, we go there. Good now. Pardon? Yeah, simplify it out here. You can simplify this out. So this is 1 to the power of a half. Remember, b is minus x. We get the minus sign. Plus a half c1. 1 factorial 1, right? A is 1 again. So that's 1 to the half minus 1 by minus x to the power of 1, right? That's the first 2 terms. Third term, It'll be 2 factorial over a half by a half minus 1 by 1 to the power of a half minus 2 by minus x squared plus plus 3 factorial. That'll be a half by a half minus 1 by a half minus 2. Right? By 1 to the half minus 3 minus x cubed. All right? So that's what the first 4 terms will look like. Remember, this expansion is not done. Right? It's not done. So put plus dot 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 dot. Okay? And then you work this out. 1 to any power is what? 1. So this will be a minus. 1 to any power is 1 minus a half, right? Look at that there, minus a half x. Yeah. Next one, a half by a half is a quarter, divided by 2 is 1/8. And I have a minus here. So I have minus 1/8 x squared. Anybody get that? Yeah. Here is a minus and a minus as a plus. So again, minus again. How much shall I get here? 3 over 2, that's 3 over 8. 1 over 16. 1 over 16 x cubed. Anybody online got that?
Yes, sir.
How got?
This is supposed to be plus 1/8.
What's that, Nathan? Nathaniel? A little louder.
So I think that's supposed to be plus 1/8, unless my thing wrong.
Plus 1/8, yeah?
I think so, yeah. I can't
Right,
tell
so
what that.
this is minus. Minus a half by minus a half by positive a half is minus. Minus x squared is positive. So plus by a minus is a minus.
Okay.
Right? So do we get this square this? Hello, okay there? Yeah? Right, so there's an extension to this now. Here's what it says. Right? Catch up, Randy. Catch up. All right. Here's what they want, right? And that same question, this something came in 2008. They asked to expand this, and then they said, here's what it said, right? Right. Here's what it said. Question said that right. Prove that if x is small, so that x cubed and higher powers can be neglected. So it said x is small, so any cube, any term smaller than x cubed we acknowledge, right? They wanted to prove this. Prove that the square root of 1 minus x over 1 plus x is approximately equal to this. Right? Here's what they're doing. The question said, the question said that if x is small, all the terms x cubed and larger, we ignore it. Too small. They want you to prove this. And you already have in the numerator? And you have a numerator already? So you have to work out it. And then see what it looks like that. I can't do your thing on so what again? We already have the expansion for 1 minus x to the half. All right? We got to figure out what to do here.
You can put these two over.
All right? All right. I'll give you a hint. I'll give you another hint, yeah. So you don't explain it to Adam, right? Wait, anybody can tell them all what you think before I give you the hint?
You make both with the brackets and then put it for.
So you take both of them.
Find ratio.
Say again, Nikash.
Yeah.
Put the power half here. How that gonna look like that? So work out this first, right? You work out this, and then what are you gonna do? Divide them. Close there, but you see, if you divide, you end up with problems. Anybody seen anything else? Huh? What I mean? What else flip around the sign of me? I thought you meant something else. Huh? Rationalize. Well, yeah, you can do that. Yeah, you can kind of do that. Right. That's what you want. So instead of writing it like this, you want this.
Oh, yeah.
So this is the expansion you want to get. If you have this and you can multiply by this easily, and you should get something like that. Should. Go ahead, have fun. Right, so work out this summer. Work out this, right? What's it? Work out this and multiply it by this here. No, but we were suggesting to divide. So you'll end up with problems because what's your answer? When you divide two polynomials, that'll be different. You have to go and use long division. All right, so that will work there. Right, very good, Daniel. Sorry? This is module. It is the end of a module. This is module 2. We have this and we have roots. Newton Raphson on them. I do it. Let's hope you read a book and figure it out. I always do that. I always. We have this to do and then we have that last one, right? We have this, or you all would say we have this to do, Taylor series and McLaurin. And then we have the roots to do on that. Right? Taylor series where you have to differentiate and then plug in a value. As we do today for sure. If we can squeeze in roots, we will do that. Right, hurry up. Work out this. Expand this out, please. All right, but to be honest, the question gave you this first and then asked you to figure it out. I just didn't give it this. But the question made you did this in part 1, this in part 2, then they gave you this. Right, but I just wanted to see if you have figured it out.
Question was like,
Go ahead. We'll go up. Let's see what you get. Not like x2 then x cube once more, right? Anybody guys? Very good. All right, let's take a look at it. Is that me as well? So what we'll get here? So when you work this out, 1 plus x to the minus a half, what you all got? So it's 1 to the minus a half plus minus a half c1, right? By 1, I just put in 1 because 1 to any power is 1, right? By x to the minus a half plus minus a half by minus a half minus 1 over 2 by 1 by x to the minus a half squared. Right? So this is minus a half. Why do here, boy? What did I do there? So this is 1, this is x to the 1, right, squared. Do I need the x cubed term? Do I need the cube term? No, so I can stop right there. What does this simplify to? This is 1 minus a half x. That's number what I told you before this. I was listening. Right? X is small, so all the terms cubed and onwards they ignore it. Right? That was the beginning of this. So I don't want this either. Watch. So I don't want this here either. Right? So that's 1 minus a half x, and I got what you all got here? Positive something, positive 3 on 8 or something. Positive 3/8 x squared. All right. Now we're coming back here now. We're coming back here because we want to show that this is equal to this. So 1 minus x to the half is 1 minus a half x minus 1/8 minus 1/8 x squared multiplied by this, which is 1 minus a half x plus 3/8 x squared. Right. Question said to ignore all the terms. Ignore all the terms that are x cubed or more. So 1 by 1 is 1. 1 by a half minus a half x. 1 by this positive 3/8 x squared. So I'm done with the 1. Now here minus a half x. Minus a half by minus a half is plus a quarter. Minus a half by this. I don't want that term because that's cubed. Okay. I don't want this by this. Now here now. This by this will give me minus 1/8 x squared. Do I multiply this by this? No, because that will give me a cube term. Right? I just simplify this out. A half minus a half is a whole. Right? 3/8 minus 1/8. 3/8 minus 1/8 is 2/8 plus a quarter is a half. That's it. Where you lost? Pardon me? This is 3/8, right? And this should be positive. That's what you're asking? What's on it? Minus a half, minus a half. Nah. the calculator. A half plus a half is how much? A half plus a half is a plus. So minus a half is what?
So right now, one from the I think he might see it.
That's what you're saying, right?
Yeah.
So minus a half, right?
Yeah.
So I can factor out minus a 1.
That's why I think I would. Where is it?
All right, nice. So we don't expand. We don't use binomial. Let's try a couple questions. Oh wait. We have one more exciting part to this. Last part to this, right? This is part 3.
Right.
Right, what you say? Here's the challenge, right? Here's the question said. Hence, Adam, right? The last part says, hence, by taking x is equal to 1 and 17, show that root 2 is approximately equal to 1635 over 1157. How are we doing that? Are we going to show that root 2 is this? But the question said, take x as 1 and 17. What you'll do? What's it good? The one that showed this equivalent to this, and they said take this. So where will you put this? In front? Yeah, coming back here. So you're coming back here and you're putting x is 1 and 17, x is 1 and 17. And you want to find a way to make this what? Root 2. Okay? You want to find a way to make it root 2 and equal to that value there. All right? Try it and see now. If you can't, I will help you. Right? But follow the instructions. The question said, take this equal to this. Right? And then show this. So put it in there and then see how you can turn it into root 2. All right? Put it into there and see if you can turn it into root 2. No calculator, no tables, right? Question said, yeah, question said no calculator, no tables. Well, you book it. If they recognize you use a calculator.
See, we can calculate it.
Do it now. And you go back there again, buddy. But you agree a half plus a half.
Yeah, so the sum will be so we say minus 0.5 plus minus 0.5. We say minus 4 and still don't understand. Another question?
William again? William? Give me this question because of you and say this is what your exams look like. How are we doing this? Any answers online? You all got it? William? How are we going to turn this into that? Right? Again, they told us what to put x as, right? So 1 minus 1 on 17, 1 plus 1 on 17. How much is this?
16 on 17.
This is 16 on 17 over 18 on 17. When I divide this, what you will get? Square root of. When I divide this, what you will get? 16 over 18. Right? How are we going to turn that? Well, we can simplify this a little bit, right? But well, this way. If you divide these two and simplify it, how much will simplify down to? 8 on 9. How are you going to turn it into 2? Take the root at the bottom and the top. So when you root 9, you will get 3. When you root 8, you will get what? You will get 2 root. Right? So it means that if I put x is 1 on 17 in there, the answer is what? 2 root 2 on 3. All you have to do is what after that? All right, close enough. But what you're going to do is this, right? We know that when you put 1 on 17 there, you are getting 2 root 2 all over 3, correct? And that is approximately equal to putting the same thing here, right? So 2 root 2 on 3 is approximately equal to what this is. Exact value. What this is as a fraction. Because our answer is like a fraction, right? We want to give it back as a fraction. What this is, put it in the calculator. No, they mean no calculator for actually putting in what's root. Sorry, 578. Right. And now you make root 2 the subject, right? So carry the 3 here, carry the 2 here. That's okay? So root 2 will be 545 multiplied by 3 all over 578 by 2. So what I was trying to say here is that our answer is really 2/3 of root 2. Right? So if you multiply it by 3 and 2, we'll get it. And if you simplify it, you'll get 1635 over 1156. Okay? So you had to make the substitution, simplify it out, and get it in the term in the form of root 2. Huh? Better get it in the form of root 2, right? All right, so that's the theory behind binomial. Let's see if we can do a full one. That was a nice one. The one that we did in 2008. Sorry? Sorry? We have time. We have time. One more, and then I'll give you. Let's do one like this before we move on to the topic, right? All right, let's try 2013. And I'm thick here, so I'm gonna have to. Last one, then I'll give you. Is that again true? Is that again true? All right, last one. Last one here, Olivia. Let's see now. Right, that's hey, last one. I see the power of 4, right? That's the 4th root, so it's the power of quarter. Up till x squared, right? Up till x squared, move to that.
Oh.
Huh?
No, see, man, no. No.
Ah, up to the term contain the next way, yeah. I started checking to make sure we're doing it good. Andy, quarter minus a quarter minus a quarter is how much? Minus a quarter plus a quarter. A quarter plus a quarter.
Right.
You might need it here, I don't know. I just see quarters there. So you might need it. Right, so here's what. We have 1 to the quarter plus a quarter C1 by 1 to the quarter by x to the 1 plus a quarter by a quarter minus 1 2 factorial right? So that is 1 plus x, right? And then we could work out 1 minus x to the quarter one time. So that'll be 1 to the quarter, right? A quarter here. Here is still 1. Here is now minus x. Here will be a quarter by a quarter. Part 2 is up here. I just wrote it here in case you then write it down, right? All over 2 factorial by 1 by minus x squared. Right? This is 1 plus a quarter x. What we got here? Minus what? What you all got here? Minus 332? Yeah? Minus 332x squared. Right? So that would be for 1 plus x to the quarter. Now we have to work out this one. So that will be 1 minus a quarter x, and get minus again. Get minus again, right? Correct? Well, I get two minus signs here. Yeah? Okay, finish it up. Finish it up. Let's see what you get. You start the next part. X has 1 on 16. Well, I write it here for you, boss man. I write it here for you. Right? If x is 1 on 16, they want you to compute this. If x is 1 on 16, they want you to compute this. They want you to take this and work out this. Welcome. So this will cancel here. 1 plus 1 is 2. Minus 3 is minus 6. Right? Or we can simplify it further. 3 over 6. All right, Andy. The game, Andy. Right, now we're going to put x as 1 on 16. Are we finish it? Right, put 1 in 16 and see if we can figure out what is the fourth root of that. Of course, you have to use this here. I simplify it out because this has to be, this plus this has to be the fourth root of 1 on 17, right? Simplify it out, see how it looks. You have to make this look like what they want you to get and compute the answer.
Why?
Right? So when you work out in here, you'll get everything over 16. You'll get 17 on 16. You'll get 17 on 16 to the 1/4. Here you will end up with over 16. You'll end up with 15 to the 1/4. Is equal to, anybody work out this already? 2. Oh, I'll give it a time. 2. This. This. Yeah, this it. Question said 4 decimal places. How much you get with this right hand side here? Why didn't work it out like that? When you work out here, 1.9993. Okay. Now you still have to do some work on the left side. Eh? The left side will be the 4th root of 17 over 16 plus the 4th root of 15 over 16 is equal to 1.9993. This is the 4th root of 17 over the 4th root of 16 plus the 4th root of 15 over the 4th root of 16 is 1.9993. How much is this? 2, right? So we can multiply everything by 2. And we'll get 2 by 1.9993. $3.999. Yeah. This is 4 decimal places. But ideally, you kind of do wrong. Okay. You just multiply the whole thing by 2. Multiply this by 2 to get your answer. Was it? You okay with that? So this brings us to the end of expanded binomial, right? So binomial is where you have like an expression in the middle. Now we're going to learn to expand functions. We're going to learn to expand sin x. Sin x has an expansion. Ln x has an expansion. All right? So I'm going to give you a 6-minute break now. Right? Right? I'll give you like a 6-7 minute break and then we start McLaurin's and Taylor. If you all want, we can do all the whole thing today, the whole syllabus today. And right? So let's do McLaurin's. Right? Do McLaurin's and Taylor series. Let's take a little break. I'll give you a 6-minute break, right? Huh? No, it's only happened there, you know what? Huh? Yeah, there was some in the cafe. All right, online, take a little break. We'll start back in, I'll tell them 5 and they'll come back in 10. So between 5 to 10 minutes, right? If you want to read ahead, you can read up on McLaurin. Wait, did I send all those slides? Did I send all these slides with McLaurin? No. Yeah, send us slides. Yeah, we want to
Right.
I teach anybody else? Alright, let's take a look at McLaurin's and Taylor. Right, so as I was saying before, right? Ready? So as I was saying before, sometimes we need to expand functions. Right, sometimes we have to expand functions that look like this. And we can't use binomial here. We have to use a next form of expansion called Taylor and Maclaurin's, right? I'm not too sure, but I know some schools, their formula sheet has Taylor on it. Right, but everybody else who has Maclaurin's for sure. All right, so let's take a look at the Taylor expansion, and then I'll show you how to go from the Taylor expansion to the Maclaurin. The only problem with this is that you'll have to remember how to differentiate. Right? So hope you remember how to differentiate, product rule, and right? If not, it will look hard, right? Right? Of course, there are a few conditions that you need to know for it to work, but this is the expansion.
$12.
Yeah.
Relax.
So what?
All right. So this is Taylor series, right? All right. So Taylor series. So this expansion here is basically an expansion, right? It allows you to get a different version of the function given, and these are two roots of the function, right? And at this level, it's always going to be differentiable. All right? Right. And for Taylor, it must be defined around some value A. So if it's defined around 2, you're making sure you put 2 everywhere here. And for Maclaurin's, note that Maclaurin's is the exact same formula. Right? Exact same formula, but x is equal to 0. Same formula, but x is equal to 0. So once you learn Taylor, you know Maclaurin's. Right, so as I said, you need to be able to differentiate in order to do this, right? Ready? Right. So once you know this, please remember that all you're doing here, you're putting A in f of x. This is first differential. This is first differential, Jude, and you're plugging in A. This is second differential, I'm plugging A, right? Okay. So those are prime sign is just differentials, right? Let's try one. Yeah, it is a word. Right? But every function that you get at this level is differential. Some functions are not. All right, so let's find the first. Let's find the first 4 non-zero terms. Let's find the first 4 non-zero terms of f of x is equal to the square root of x about x is equal to 9. Ready? So when you're doing this here, take a look here. Take a look here, right? All you have to do is just find these terms. Okay? So let's find f of 9 first. F of 9, actually, I like to write this first, right? F of x is equal to square root of x. So f of 9 is the square root of 9, which is 3. All right? So we okay here. Now we have to find f prime x. What's the first differential of this? Right, please remember that square root means to the power of a half, right? So what will this be? It will be a half x to the minus a half. And you want to get f prime 9 now. So that'll be 1 over, because of the minus sign, I write it like this. 1 over 2 by the square root of 1 over 2 by the square root of 9. That's 1/6. Yeah? There's 3, right? So that's 1/6. So we have the first two values, right? Remember, it's the first 4 non-zero, right? Go again. And what you got? Right? What we got here now? Second prime is what? That'll be minus a quarter. See, Andy? A half by minus a half is minus a quarter. Right? Minus a half, minus 3 and 2. Right? Now f double prime 9. You can just put it in calculator if you don't want to rewrite the form and square roots and then cube. It will be minus a quarter by 9 to the minus 3 and 2. How much you got? Should be a nice fraction. 108. And then we do one more triple prime. Triple prime will be this by this, which will be positive 3 on 8 by x to the minus 3 and 2 minus 1 is minus 5 on 2. Right? Then you have triple prime 9. Right? So that will be 3/8 by 9 to the minus 5 on 2, which is how much? 648. All right. Nice. So therefore, f of x, now I can use the expansion, right? F of x will be f of a, which is 3 plus x minus 9. You have to write this up because the function is about 9, right? So a is 9 by f prime a, which is 1/6. Right? So we should put the 1/6 in front of it. Plus x minus 9 all squared. F double prime was minus 1 over 108 plus x minus 9 cubed. Don't expand this, but as it is by 1 over 648. And that's 1, 2, 3, 4 non-zero terms. Oh, sure, yes. Right, this is 1 factorial, this is 2 factorial, and this will be 3 factorial. Right, so this f of x now is equal to 3 plus 1/6 x minus 9. Yeah, you could multiply if you want. Plus, what's this here? That'll be minus 1 over 216 x minus 9 squared. Yeah, and the last one is what? What's the last one? What you get for the last one, Nikas? Just show him the answer. What's the last one?
Yes, sir. For that, the last line.
I know who took all now. It's getting for me there. 3, 8, 8, 8. That's it. So that's your first 4 non-zero terms. This is your expansion for the root of x about 9. All right. If I ask you to find now, hence, find the square root of 9.5. What you'll do? Yeah, that's all. Plug it in for x. Okay. So if you see the square root of 9.5, you plug it in. Okay. And compare the answers and see now. So the square root of 9.5, check the real answer and what you get after the formula. So you'll get 3 plus 1/6 by 9.5 minus 9 minus 2 1/16 by 9.5 minus 9 squared plus 1 over 3888 by 9.5 minus 9 cubed. Of course, you'll recognize that this is 0.5, right? So you can just write 0.5, 0.5 squared, 0.5 cubed. Otherwise, make you up. Look it out for me now, please. We'll say you're almost there. There's the principle behind it. Once you understand this, you can take a little sleep and do the next one. Right? And what would be the difference, Andy, if it was McLaurin's? If it were McLaurin's, how would this change? Right, when a is 0 here. So everywhere you see a 9, that would have been 0. How much you got? When you work out this? When you work it out the long way? 3.08. And what's the actual? 3.1. For this, it's supposed to be close here. Because as they go further, it gets here more than 60. Right? Any questions online? That's it. That's it for Taylor and McLaurin. That's all you have to know. Let's try a few now. Right? Sometimes you'll be fortunate. Wait, here's something different. Like kilo. Oh, I don't have a 6. Oh, kilo now save message. Right. Huh? Right. Next step. Next step is, so you'll understand the difference between Taylor and McLaurin, right? Taylor has a value it rotates about, McLaurin doesn't have a value. All right? So let's try one. Sometimes you'll be lucky and you'll get questions. Lucky is a good word here. Lucky is a good word. Right? Sometimes you'll be fortunate and you'll get a question with 14 marks on this. All that we had is the differentiation. Right? Exactly. That's all I like to hear. So let's try this here. There was one for 14 marks in 2014. 2019, a nice one too, I think. All right. Let's try. All right. Let's try this Taylor first, then we do our McLaurin. Let's try 2017, number 3A. 2017, number 3A. I'll give you the important part, right? Right? Determine the Taylor. Right? Determine the Taylor expansion. Right? Determine the Taylor expansion about x equal to 2 for try this please. Taylor expansion about x is equal to 2 of the function ln 5 plus x up to x cubed. Right? All right, before we start, let's just look about how to differentiate that. All right, because I'm not sure we can remember how to differentiate that. Right. How do you differentiate this? X plus 2 is the right. X. Right. Let's change it. 3x plus 2. Right. 3x plus 2 is the denominator. Right? 3x plus 2 is the denominator, and the numerator the differential of this. Right? But how you can differentiate this now? All right, quotient rule, or you could write 3 by 3x plus 2 and use shortcut method, right? You okay with that? Yes, you could use quotient or you could use the shortcut method and work it out, right? Go ahead. Right, bring down the power, differentiate the bracket, go back the bracket, minus that. Okay, go ahead. Do this for 5 marks.
5 marks.
6 marks, 6 marks, sorry. 6 marks. 6 marks.
rotation of the sun.
Right, try that please.
What do you want to try?
Of the x cubed first. Let me see now, boy. Let me see. What is called heights?
What's that?
Who?
Yes, yes, they did very well. What is that? Oh, oh my God. You
All right, so f of x is equal to ln 5 plus x. Now, what is f of 2? F of 2 is ln 7. Leave it like that, right? F prime will be 1 on 5 plus x, or we could write it as x to the minus 5 plus x to the minus 1. F prime 2 will be 1 on 7. So you want to get 1, you want to get x squared up until what, to x cubed. So we had to go 3 differentials. Oh, it's 6 marks. Yeah. So this will be minus 1 by 5 plus x to the minus 2. So that's f double prime 2. Pardon me, sir. Minus 1 on? Oh. Minus 1 on 49. Triple the prime. We'll get 2 by 5 plus x to the minus 3. Triple the prime. And we shall get what? How much we get here? 2 over 343. 7 cubed. Yeah. Amber. Any questions online? Online? All okay? Yeah. All right. So where did I reach? All okay? Did you have some people? Harris, you okay? Justin? Floyd, are you okay there? So I'm just going to take it now and substitute, right? So it means that f of x is equal to f of a, which is ln 7. Huh? Equal to x. Oh, here, remember f of x. F of x is this, so f of 2 will be 5 plus 2.
Yeah, it's the same thing. So f of a.
Oh, sorry about that.
Yeah, f of a.
Sorry, what? Yeah, and some, yeah, sorry, that's my mistake. They have access to what? Right? It means they have access to write that down. Right, so ln x plus x minus 2, f prime a was 1/7, right? Right, plus x minus 2 squared over 2, because it's 2 factorial. Where's double prime? Double prime is minus 1 on 49. Right? Plus x minus 2 cubed all over 3 factorial, which is 6, by 2 over 343. All right, and then you just work it out. Oh, that's an f of 7. Pardon me, sir. I will work it out already, sir. All right. And this is minus 1 on 98. What's this here? What's this here? So divide out here. What's this here? 3 by this is how much? 1029. Yeah. X minus 2q. All right. It had a small little typo there, but I think they meant in part 2, they want to get f of 7 minus ln 7. What you'll do? What you'll do? They ask for this after. They have f of 7 minus ln 7. Plug in 7 into here, and then whatever you get minus ln 7. Okay? So f of x minus ln 7 is basically ln 7 plus 1, 7. 7 minus 2 is 5, so I put in 5 one time. Minus 1 on 98, 5 squared, plus 1029 over 7 minus 2 is 5 cubed. Right? This is f of 7, and then you're minus in ln 7. Right? This will cancel with this, and then you'll get a value for this in the calculator. Well, okay, how to get f of 7? Yeah? F of 7 is just plugging in 7 wherever you have x. Okay? And then you work it out, and you minus ln 7. All right? Let's do one more Maclaurin's, and then I will just introduce roots to you. And the last thing we do next week. Well, we can finish it off, just we can follow up. Please remember to use it 4 months for all the fractions.
So you're passing on a sheet class.
Huh? How much you got here? Huh? What's this other? Point? 5.8. All right, let's do one more. 14 marks. Plenty differentiation, just way to understand the concept of Maclaurin's, right? Did I give it a long one? All right. Now you do a medium, right? All right, now that 14 marks is plenty. I don't want to make any mistakes on it. Right? Let's try 2019 and we're done. On with this topic. All right, so let's take a look at 2019, right? Those who write in, I'll just take a little quick and I'll start, right? I differentiate sine. What's the differential of sine 2x? Huh? All right, good. Last one. Yeah, time is plus 0. Yeah, plus 0. Yeah. How you study class?
I message you.
She messaged me and then he messaged me.
I'm not sure about your mother.
Oh yeah, last one, Jude. How are you? Huh? Maclaurin's. Right, please remember Maclaurin's x is 0, right? Well, a is 0, right? Let's do a Maclaurin's there. Right, up to x4, right? How you differentiated x sine x on 2?
Yeah, multiply.
Product rule, right?
Yeah.
Right, product
Yeah,
rules.
but if you keep X class, it's okay.
I want to make sure that's all I want to hear, right? Product rule. Right, so you had to use product rule and then product rule and then product rule. Up to what? X to the 4th. 8 marks for that. 8 marks for that. Right, so today's entire class was about series, was expansion, right? Power series. You know, all different types of power series. How to expand polynomials, how to expand functions, how to expand. Right, GL0, yeah, GL0 is 0. By the way, these questions normally in radians, right? It will make a difference here, but these questions are normally in radians. Last question, who's it? William, last question. Huh? Product rule. What's the differential of x? What's the differential of sine a half x? And it is a half cos.
Half cos X. X over 6.
So then go again.
Which
So
is
Bara,
the second preference.
you wrapped up already?
Huh?
So you had to use product rule up until x to the 4th, right? So that's 1 way, that's plenty, boy. Unnecessary. But it's marked, so you gotta go there.
Half cos X over 2.
Or do you want to go till cube then? Huh? Go till cube then. Right? Don't go all the way. Go till cube. Oh no, no, no. Veio, como lá vai? She called me a liar. That's crazy. That is crazy. Oh no, I now remember why we cast up at Q. But this will be 0, this might be 0.
Yeah, the first two is 0.
First 2 is 0? So you might be no problem. That's why. Right? So this might be 0, this might be 0. So if you stop here, it says 2 terms. Right? So you might have to do. Once you understand. Alright, well, we can stop at Q, but still. There's not enough terms now. Right? And last part is G of 2, right? How are you getting G of 2? Oh, yes, plugging it 2, right? Right, so my first differential, this is U and this is V, right? So it's X by 1/2 cos X on 2 plus the differential of X is 1 by sine 1/2 X. Right? X on 2 is the same as 1/2 X, right? G prime 0. This will be 0. This will be 0. Right? Because you have a 0 here, right? Now double prime. Double prime means that using product rule here again, you don't need product rule here, right? So product rule, this is U and this is V. Right? Those skip out any steps there, do it piece by piece, right? This is X by the differential of 1/2 cos X on 2 is minus 1/4 sine minus 1/4 sine X on 2. That's okay? The differential of 1/2 X on 1/2 X is 1/2 by 1/2. Differential of cos is minus sine, right? Plus the differential of U is 1 by 1/2 cos X on 2. Right? This is the differential of this. Now you want to get the differential here. The differential of sine is simply 1/2 cos 1/2 X. Right? Now you want G double prime 0. Right? When you put 0 here, you'll get 0. When you put 0 here, cos 0 is 1. So you'll get 1/2 by 1, which is 1/2. When you put 0 here, you'll get 1/2 again. So I got 1. Anybody got that? Put double prime? Yep. Double prime? Nabil? No. But you got this for the differential? You product rule here. Find the source, right? We find the source. Right? So the problem is you have to use product rule. What about here? Product rule again? Right? Product rule here, right? Remember, if you're still not seeing it, right? You could use product rule all the time. Even here, you don't have to use product rule, but you could treat this as a product. Right? It's always safer to use product rule than to not use it. Pardon me? Target 0 for the Q. Cos. Yeah, you should get to me.
There's X by.
Oh, it's by the differential. Right, so try triple prime. Try triple prime and you can see you get 0. Right, you could just add these two, so you don't have to put them together. 1/2 and 1/2 is a whole. Pardon me? Yeah, it's 2019. Us? Yeah, yeah. That's what it said, but I was just saying.
If we had to go up to 4.
Yeah. Because we never done x 0 till here. So this is x by the differential of sine is cos. So that'll be minus 1/8 cos. This is u by v again. Cos x on 2 plus 1 by minus a quarter sine x on 2. This is the differential of this product. Remember, I had this already. A half and a half is a whole. The differential of cos x on 2 will be minus a half sine x on 2. The reason I have this is add them, right? A half and a half is a whole, Andy, right? So this plus is a whole, so the differential of cos a half x is minus a half sine. So now g of triple prime 0 is 0. I'll get 0, I'll get 0, I'll get 0. And then we have to go to the power of 4. And then we put this power of 4 minus a half. Right, so the power of 4 is minus a half. Anybody else get that? Shibara, say yes. Minus a half. All right, so the final answer, yeah, you don't get minus a half too. Right, final answer is f of x is equal to f of 0, which is 0. Next term is 0, so we don't bother with that. The squared, that's here. So this is 0, this is 0. So here now, it'll be x squared on 2 by double prime, which is 1. Triple prime is 0 to the power of 4 will be x to the 4th over. Yeah, x to the 4 over 4 factorial by minus a half, you got, right? Yeah. So the final answer for f of x, remember, is Maclaurin's. This will be 1/2 x squared, 1/2 x squared minus 24, and 24 by 2 is 48. Right, so you'll see why we had to go to the x to the 4 term, right? Because we had 3 zeros out of the first 5 terms. All right, so this is your Maclaurin. Just remember, just plug in 0. All right. As I said, in your formula sheets for exam, most people don't have. If you have the old one, you don't have Taylor series. You have Maclaurin. You have to learn Taylor, right? But I've seen some recent ones where they had A in it. But I don't know the examiners just work with it all the time. Huh? Yeah, it's have Maclaurin, not Taylor. But it is. No, yeah, but Maclaurin wouldn't have the E. So you might just, if you don't remember where the A is, you wouldn't have. Well, that's whatever. So it's nice if you know the Taylor. If you give it the Taylor, you can figure out the next one. All right. So that is it for Taylor. That's it for this expansion. The last thing we have to do, I just want to introduce it so you have an idea, or you may have done in school already. The last thing we have to do is to be able to estimate a root. Right? A root is basically a solution for a function. So we have to estimate the root, and we use a few theorems: intermediate value theorem, interval bisection. Right? All of those things are used to estimate the root interaction, right? Linear interpolation. Right? So we'll do all of them next week, and just so you have an idea of what's going on. Right? We can finish it now. No, I'll show you the formula.
No, I just take your time.
So I'll do this exam before next week.
Yeah, well,
So at least you get everything right.
yeah, exactly.
That's all you want.
I don't know. Really?
No. Okay, well, I'm going to do a video. I can do a video on that too. So you want if you want to look at it. But it's easy. It's just to know the steps. All right. So I just wanted to introduce it. Any questions online on Matt Lawrence? All right. So watch this here. Let's take a look here. You don't want to write anything. Just to give you an idea of what the rest of the module is on, right?
No.
Right. So watch this here. What you have is a function. See that line? That line is the function, right? And what we have to do, we have to find the root. Basically, we cut the x-axis, right? And what they do initially is they give you limits of where the root could exist, right? So what you have to do is to use the limits to try to approximate that root. So the first thing you'll do is intermediate value theorem, where you're going to plug in A, find f of A, plug in B, find f of B, and there should be a sign change. That's the easiest one, right? And then, but that will just tell you what a root exists between the others is actually find the root, right? And one of the examples is interval bisection. So what did it do? In interval bisection is that they add up these two, they get a new limit, and they check and see if it lies between them. Then do it again, add up these two, their next limit, and get closer and closer until you reach it, or close enough. Then you have linear interpolation. That's a formula you just use. Then you have Newton-Raphson, which is also a formula developed to help you find alpha. Right? But all of these use conversion tests. So that they try to get closer and closer to the answer. All right? So next week we'll do this. All right? What I could also do is I could also do a video for you, and I'll send it on just about 15 minutes long. With the accent. Right? And that will wrap up your module 2. So hopefully you can go over everything for your exam. Right? Please try and study for the exam. Send it around. I get to stand so maybe I can no Williams.